Hey everyone, and welcome to WitCode, where in today's video we're going to create an application that scans your private network for the registered IP addresses and also the IP addresses that they are communicating with. This will be done with Tkinter for the GUI and Scapy, a packet manipulation library for Python. So you can see what we're going to be building here. So what I can do is enter IP subdomain. So if I run something from the command prompt, such as if I'm using Windows, such as ipconfig, and I see my IP address, I can see that I am in the subdomain of 192.168.0. So what I can do is I can sniff for other IP addresses on that subdomain and also who they are communicating with. So if I type in this here and click start sniffing, you can see all the IP addresses that get registered. If I click stop sniffing, you can see that the application stops. And then if you click on not only loads these, but if you click on this plus here, it shows the IP addresses that they are communicating with as well. So you can see other IP addresses, and there will be multiple, and you can start sniffing again and see more and more IP addresses get loaded. And these are just the packets that have been found being logged out to the console. I should also mention that I'm using the Windows operating system to run this application, but it's recommended that if you're using Scapy that you use Linux as the operating system. However, we can use Windows if you download this extension here, WinPcap, which is basically a package analyzer for Windows. And then Scapy will run fine if you're using this. So if you are using Windows, go to this link here and download it. I'll leave the link in the description. If you're using Linux, I believe this should work fine. So now let's get started by creating our application, or creating a new project in PyCharm. So I'm going to File, New Project, and then I'm just going to select the location. I'm going to do a new virtual environment. I'm going to go from there. So now that our project is loaded, let's just create our main file that we're going to be working with. So I'm going to right click, I'm going to do new Python file, and I'll just call it WitCode like this. So first, let's get started with our imports. The first thing we're importing is the Tkinter package, which is a Python GUI toolkit. This is what we will use to build our GUI. So I'm going to import Tkinter as TK. And we'll also import the TTK module from Tkinter, which is a more modern and configurable GUI module for Python. So for this, I'm going to do from Tkinter import TTK. Next, we'll use the brains of our application, which is Scapy, a Python-based interactive packet manipulation program and library. We will use this to get the IP addresses on these packets. And so to do this, what we first have to do is we have to go to our project interpreter. So I'm just going to go to Settings, Project Interpreter here, and we have to use this version. So come over here and search for Scapy. And you can see it right here, and then we just click Install Package. Now that Scapy has been successfully imported, we can use it. So let's just exit out of this. Press OK here, and now let's import it. So we're going to import scapy.all as Scapy. And next we will import the threading module, as our program will require multiple threads. So to do that, we're just going to do import threading. And then finally we'll be using the collections module because we will be taking advantage of the default dictionary that is provided. So then on another line, we will do import collections. Now to start coding. First thing we're going to do is create three global variables: thread, should we stop, and subdomain. Thread will be created from the threading module and will be the thread to sniff for packets on the network. Our thread will listen for events on the UI. So let's create it by just doing thread equals none to initialize it. And then should we stop is a boolean that will determine whether we should stop looking for packets or not. It is true at first because we don't start sniffing until we click start. So we're going to make a variable should we stop and set that equal to true initially. And finally, subdomain will be the subdomain of the IP addresses the user wants to scan. It is retrieved from the Tkinter entry box we are going to make. So right now, I'm just going to set subdomain equal to an empty string. Now we're going to create a dictionary from the collections module. We're using the default dictionary, which is a dictionary that when we look up for a key in it that doesn't exist, it will create it instead of throwing an error. This will be useful when we are searching for this dictionary to see if an IP address is already in the dictionary. So to do that, I'm going to name it source IP dictionary. I'm going to set that equal to collections.default dictionary. I'm going to pass in a list. Now we can start building our GUI, of which we'll be using the Tkinter package. First, we use the TK class, which is instantiated without arguments. This creates the main window of our application. So if I just click down here, I'm going to name the variable root, and I do the TK module.tk like this, it will create our main window. And then we're going to reuse the returned instance of this to set the height and width and the geometry method, and then we will set the title to WitCode. So I can do root.geometry and then pass in a string for the size, and it works by height by width like this. And then we want to set the title, of course. And I'm just going to set this to WIT codes. We have to escape this if we are using an apostrophe. So WIT codes, escape it like this. Packet analyzer. Now let's add our two labels. One of them is the main title, and the other prompts the user to enter a subdomain to scan. For this, we'll use the label class, which is used to display text or even an image with Tkinter. The first argument is the root or the parent container, and then we can specify the text and even change the style of the font. So let's put this back here. And let's make a label. Let's do tk.label, so we specify the parent, and then let's add the text that we want to use. You may also notice that instead of explicitly returning the label to a variable like we did here with root, we're just going to call the pack method on it directly. This organizes the widget in blocks before placing them in the parent widget. By default, these will be centered and to the top of the frame. Now let's create our tree view that is going to hold all of our IP addresses that we can find. To do this, we are going to use the TTK module and the Treeview class. So let's create something. Let's create a variable called treev for Treeview, and we're going to use ttk.treeview. And the first argument is once again the parent element, which is our root or Tkinter window. So I'm going to do root, and then we can also specify other options. And what we're going to do is a height. So we're going to set height equal to 400. Then let's create a column in which we pass the hashtag 0 for our first column. This column holds the tree together and houses the plus sign that is used for expansion. So we're going to do treev.column and just pass in hashtag 0 like this. Now we can create a frame using the Tkinter frame class. A frame is basically a small window that we can use to house widgets in. This frame is going to house our buttons, so I'll call it button frame. So I'm going to make a variable button frame and set that equal to tk.frame, and then of course we pass in the constructor takes a parent element, which is our window that we created here, and which is called root. And then we can create our buttons that we want to pass into this frame. So we create them with the button class, which the first argument is once again the parent, and this time that'll be the frame. So if we do tk.button and the first argument is the parent, we can do button frame. And then we can pass other options. The most important one is command, which is the function that will be executed when the button is clicked. The others are basically just for styling. Let me decrease this window a bit here. Now let's add our button frame to the main window by using the pack method, and let's add a couple of arguments. We're going to use the side, which specifies where the frame will be located in the window. By default it is top, but we want it at the bottom, so let's use the argument side and then set it to tk.bottom. So we're going to do button frame dot pack. We're going to use the side argument to be equal to tk.bottom. And finally, let's do pad y, which will add space around the frame in the y direction. In other words, spacing above and below the frame. So we can do pad y, and let's just set that equal to 10. And then to actually make our GUI show, we have to use the main loop function on our TK container. Main loop is an infinite loop used to run the application, wait for an event to occur, and process the events as long as the window is not closed. This is why we need a separate thread, as to monitor for packets, we need one thread to run this loop and another to sniff out packets. So to run this, all you do is root.main loop like this. Now we can start creating the more interesting stuff. To do this, let's first give our start button some functionality. So we passed it the function start button right here, which is a command which means the function will be executed when the button is clicked. What we're going to do with this button is change our global variables appropriately, get the input from the entry box, and spawn a separate thread to run our sniffing function. So let's create this function up here. We're going to call it def start button. And what first happens, let's just print start button clicked. And then let's import our global variables that we want to edit. So we're going to do should we stop. We're going to do also use thread. And we're going to also use subdomain. Fix the spacing here. And so when the start button is clicked, of course what we want to do is we want to get the subdomain from the entry box that we made with Tkinter. So I'm going to do subdomain equals subdomain dot underscore entry dot get. And I believe we forgot to actually create our entry box. So let's do that. It should be right underneath this label here. So we're going to do tk.entry and specify root. And what we also want to do is we want to return this to a variable, which we have called subdomain entry. Set that equal to this, and then we will actually want to add it to the window. So we're going to do subdomain entry.pack, and let's add some arguments. So what these are here is, of course, iPad Y and iPad X means internal padding. And what that'll basically do is make this entry box bigger, and then we're using pad Y, which will set spacing in the vertical direction or above and below the entry box. Now let's create our thread that will sniff for packets. What we have to do is check if a separate thread has been created or if the thread is dead. If these are true, it means that we haven't already spawned a new thread to run our packet capturing function. So let's go in here, and what we're going to do is if the global variable thread is none, which means it wasn't ever created, or not thread.is underscore alive. So if the thread hasn't been created or if it isn't alive, then what we want to do is we should set should we stop equal to false. This variable determines if we should stop looking for packets or not. We have not made the function to apply this yet, but just know this for now. And now we can create our thread from the threading module using the class thread. We pass it one argument, target, and pass it the function that we want that thread to execute. So what we're going to do is we're going to set thread equal to threading dot thread, and then of course the argument target, and the function that we actually want it to execute is sniffing. And then when the thread is created, its activity must be started by calling the thread's start method. So then we will start our thread by doing thread.start. So we've got our start button set up, so now we can get our stop button started. So once again, let's make the function reference in the command for the stop button in Tkinter. So we're going to do def, and I believe it was stop button. This function will be called stop button, and what it will do is stop the packet sniffing execution. So let's import our should we stop variable and set it equal to true because the user wants to stop sniffing for packets. So let's import it by global should we stop, and then we're just going to set should we stop equal to true. And this is all we need to do here. Now we can start using Scapy, the Python-based interactive packet manipulation program and library. The function we'll be using from Scapy is sniff. We're going to be wrapping this in our own function called sniffing that is executed by the separate thread. This sniff method from Scapy is really the powerhouse behind our application. What it does is sniff for packets in the network. Then we can pass it arguments. So let's create a function below our stop button. We will call it def sniffing. And then what we're going to use is scapy.sniff. One of these arguments is prn, which accepts a function that is executed with each packet sniffed. It passes the packet object as the one and only argument. The function we are going to be using there is find IPs, which we will create soon to parse the packets for information. So let's do prn equals find IPs. The next parameter key is stop filter, which also takes a function. This function is applied to each packet, but this time it is to determine if we have to stop capturing packets. So let's do stop filter equals stop sniffing. We're going to create a function for this called stop sniffing. When this function returns true, the sniffing for packets will stop. Let's make the stop sniffing function real quick, which will be very simple to make as we are just going to return should we stop. So let's just go down here, add a few more lines, do def stop sniffing. It takes one argument, which will be the packet. We're not going to use it, but let's import our global should we stop, and then we're just going to return it. So every packet that is obtained, we're also checking the value of should we stop. If it is false, which means keep sniffing unless the stop button has been clicked. And finally, we're going to create our find IPs function, which will do all the logic and set the Treeview we created with Tkinter. So first let's import the global variables that we're going to need. These are source IP or the dictionary, or source IP dictionary, or the dictionary of our source IP addresses, the Treeview to hold our IP addresses, and the subdomain that the user entered to scan. So we're going to call this, of course, def find IPs. It takes in the packet as the argument, and we're going to import our globals. Also remember how the function passed to prn in the Scapy sniff function is passed to packet. We can see the details of this packet by printing it to the console with packet.show. So what we can do here is we can just do print packet.show, and this will show us all the information. And when logged to the console, we can then see in the console the individual layers. So you can see at the top, we have the application layer. Then we have the transport layer, then the internet layer, and then the network interface. Now we can work with these packets. So the first thing we want to check for is if it's IPv4 versus IPv6. If it is IPv4, the packet will have the string IP in it, and if it is IPv6, it'll have the string IPv6 in it. So we want to check for the string IP. If it is present, then we want to get the source IP and destination IP from this packet. So what we can do down here is just simply if the string IP is in the packet that Scapy retrieved for us, we can set source IP equal to packet, obtain the IP field, and then get the source IP address from it. And also we can do the same for the destination IP. So destination IP equals packet of the string IP and get the destination from that as well. Now let's check if this source IP contains the subdomain that the user specified in the entry box. We're going to do that by comparing the characters of the source IP to the subdomain up to the length of the subdomain provided by the user. So in other words, we're going to check if source IP from 0 up until the length of the subdomain that the user entered, if that equals subdomain, then what we can do is check if the IP is already registered in our dictionary. And then if the source IP is not in the dictionary, we want to add it to it. This is why we want to use the default dictionary of the collections module, is if we search for a key that doesn't exist, then we would get an error. The default dictionary would just create the key instead of throwing this key error. So then we can check if source IP not in source IP dictionary, then we want to append the destination IP to the dictionary with the source IP key. This means that we're tracking the destination IPs that the source IP is communicating with. So we can do source IP dictionary and add the source IP as a key, and we want to append to that the destination IP. Now that we've retrieved our IP addresses, let's add them to our Treeview. So to do that, we're going to use Treeview and the insert method. So let's create a variable here, let's call it row, and set that equal to our global Treeview variable, and press not index, but insert. And so the first argument is the parent, which is blank because we are calling it from Treeview. So we're calling from this here, so we can just leave this blank. And we then want the index to be the end because we are putting it at the end of the tree. So we can set the argument index equal to tk dot end. And finally, let's set the source IP address as the text. We want to return this as a row because we can then add the destination IP to this. So then let's just set the text equal to the source IP. So let's use the insert function, but this time make the parent the row we made and the text to be the destination IP. This shows the destination IPs under the source IP when you click the small plus sign. So we will do here treeview.insert. The parent will be the row we just made. Once again, we want to insert it on the end, and we want to set the text this time to not be the source IP, but the destination IP. And then we just want to place our tree in the window and make it fill the width of the container. So let's do treeview.pack, and to make it fill the width of the container, we use the argument fill, and we set that to tk.x, so it'll fill in the horizontal direction. Now we can create the other part of our if-else statement. This is where if the source IP is already registered in the dictionary. If it is, then we just want to add the new destination IP if it is not already registered. So let's go here, and this is where we'll type else. And so now we look for if the destination IP is not in the source IP dictionary, using that source IP as a key, then what we want to do is append it to our dictionary. So we do source IP dictionary of source IP, and we will append the destination IP. And we should actually move this in one more over. So this is the if for here. And now let's retrieve the row that was last selected by the Treeview. And if the source IP address matches a text, then you want to insert the destination IP address into that row as well. So if we go over here, go to the end, what we want to do is we want to get current item. I want to set that to treev.focus, which will return the row that was last selected by the tree. And then what we want to check for is if the treev.item and the current item, and we want to get the text in that item, which will be the source IP. If that equals the source IP, then what we want to do is insert that into the end. So insert, and the parent will be the current item. We want to place it at the end, and we want to set the text equal to destination IP. So once again down here, we are just adding another destination IP to a source IP that is already registered. So this is our whole application. So all we need to do now, check for errors. We don't see any, so let's run this. So I'm going to right click on this here. I'm going to say run WIT code. And you can see we have an error on line 86. What is that here? And so the error, of course, stems from the fact that inside pack, we did not specify the argument. So the argument here is side. So you want the side to be tk.left. So basically the buttons are next to each other as opposed to on top of one another. So let's run this one more time. You can see we have our thing up here. And so I know my IP subdomain for my private network is 192.168.0. And now if I type that in, fingers crossed, start button clicked, we have one more error, source IP dictionary is not defined. So let's go to the line, we can see line 49, source IP dictionary. And so we did import it up here, source IP dictionary, but I believe we must have spelt it wrong. So if we go down here, and you can see SCR instead of SRC. All right, so let's stop this. Let's run one more time. Hopefully it works this time. So let's do 192.168.0 and press start. Start button clicked. You can see the packets being put here, and you can see the IP addresses appearing on the network. So usually something that ends with 0.01 like this is a router. You can see who it's communicating with, and if we just let it play a little longer. So we do in fact actually have one more error with this, and you can see each, no matter how long we run this, it seems like it's only picking up one IP address. And the reason this is because we need to indent all this over one more time, because then it is basically checking everything for the, or if the length of the subdomain is not that, then it is doing this. So it's not actually being appended into this tree because we are not obtaining the row item and inserting everything else. So now let's stop this and run this again. Final attempt. All right, and let's see. Yep, and now you can see we're picking up multiple. So this is working better. And basically you can just leave this running so you can see each one of these is someone on your private network, and then you can actually list or see the IP addresses that they are communicating with. So this was a video on Scapy. I'm probably going to do a few more of these in the future, making interesting programs like this, and maybe just an overall tutorial on Scapy in general. But if you like this, thank you for watching. If you have any questions, leave them in the comments, and I'll try and get back to you. Thanks for watching.